Now let's take a look at this velocity time graph. And keeping in mind that velocity is a vector quantity, so we use positive and negative signs to show direction. If you look at this velocity segment that we're dealing with, the entire time we have a positive velocity. So that means the entire time, the person whose motion you're studying has to be going towards the positive direction. So having a positive velocity doesn't mean that you're at a positive position relative to the reference point. It just means you're moving towards the positive direction. So anytime we're drawing a position time graph, we kind of work backwards from a velocity time graph. Where you are at time zero is basically an arbitrary choice because you have no idea from the information given if the person is exactly at the reference point, if they're already at a positive position, or they're already at a negative position at time zero. So you just pick something and go with it. So for purely logistical reasons, since this is a positive velocity above zero the entire time, that means the person's going to be moving towards a positive direction. So I'm going to actually start out down here at a negative position just because physically it gives me more space to draw here. So if we look, the velocity starts out quite a bit of distance away from zero. That means it's going pretty fast. But as time goes by, the velocity gets closer and closer to zero. So that means as the person's moving towards a positive direction, they're slowing down. So that's going to look something like this. And it never fully gets horizontal here. The position doesn't completely level out because the velocity doesn't ever actually get to zero. It just approaches zero. So notice that position, rate of change of position's velocity, as time goes by, the slope, steepness of the graph decreases as the velocity gets closer to zero. But since the velocity never reaches zero, the position never gets to the point where it completely levels out and stops changing.